a result of what they achieved, but there seems to be some problems with some people understanding of the winding of the copper springs. I had to think a lot in how you lot are getting it all the other way around and wrong way around. And this morning we discussed it with our guys who understand these things, and then we spoke with the factory that understand these things, and it's a very easy solution to it. And I've asked Vince, and hopefully when I start explaining it, everything else, how to do the winding on the blueprint will be withdrawn, and this will become the replacement for it. That from now on, everybody knows when we talk about the winding, doesn't matter what terminology you use, we call it the winding of the coil for the power units, for gravitational magnetic unit. We started from now that they can record it and take it out. If you take a normal hand drill, this is the easiest way to do it. When you have a hand drill, you hold the drill in your hand, facing the direction where you want to put your attachment to it. On a normal hand drill, you have a forward and a backward. What it means, when you want to drill a hole, you press forward, you push in. If you want, for example, to screw into the wall with a hand screw, you push it forward. It goes clockwise, away from you. But they all have a button which you can reverse it, which means you try to take the screw out, which goes anti-clockwise or unwinding. Put your drill onto anti-clock, which is unwinding position. Put the bar which you want to produce, if you can open it, you should be able to open it. You put your bar in the drill, which you tighten it. You put your copper wire into the grooves, whatever way you can tighten it that it stays in the jaw of the drill. And once you've done that, you're all experts. I'm the most lousy guy with the hand drills and these things. Even I've done engineering, I always hate tools. So what do? You tighten your bar, your copper wire, and all you do, just switch it on. You start the first rotation with it as it goes. If I can clip it, this is a very fine, because we don't have a gauge 14 with us here in the center. What I'm going to do, I'm going to tighten it a couple of times that it has the body to be gripped. All you do, you turn the machine on and let it run away from you. And that's all you need to do. This is how you call it clockwise, anti-clockwise. That's how you make your spring, the coil. Very easy. You make it tighter as you like. You can make it open as you like. But now we answered all the questions. How do you make it? If it's a right-hand screw or a left-hand clockwise, whatever. This is how it should be. This end is this end which is towards the machine where we started is your gravitational, or if it's your center core, is the input, and the other end is the output. As simple as this. So all this misunderstanding about the magnetical and gravitational is resolved. If you look at the wire, it looks as is clockwise, but it's actually winded anti-clockwise. It's as simple as doing it this way. So a lot of you who had problem with this, you see it, this is what it's called, anti-clockwise, because when you look at it from the field coming out, you see the bend. It's the field flow. So the way we do it and the way it's been done is this way. Doesn't matter how you call it. The winding for the coils, you place it in your drill. If you have a screwdriver, other people who use the screwdrivers, you hold your screwdriver and you turn backwards with your screwdriver. That's all it is. The turning of the coil of the beam is anti-clockwise, and that's what we're looking for. That's what is called anti-clockwise turning. You turn your screwdriver, or if you have a machine, you put it, you face the wire towards yourself, and the machine builds up to the numbers you need.